Well, hello Internet, and welcome to my Julia video tutorial. In this one tutorial, you're going to learn the core syntax of the Julia programming language. And I decided to do this tutorial based off of your votes. And basically, Julia is largely used by the scientific community. And the reason why is it is fast. It's a general purpose language that can easily integrate libraries from numerous other different languages. And it has numerous libraries that are focused on those that are mathematically inclined. Like always, a cheat sheet with a transcript of this entire video is available in the description underneath this video. As well, I have a table of contents that you can just click on and go to whatever you are interested in regards to Julia, and that is also in the description underneath this video. And I have a lot to do, so let's get into it. Okay, so to install Julia, you just go to julialang.org/downloads. It's very easy to install, and it works on pretty much every operating system. And I'm not going to waste your time in regards to how to install that. I'm just going to jump in and start writing some code. Alright, so on the left side, you can use any type of IDE or text editor you want. I am using Atom, and right here I have Atom. Over here I have the terminal. And basically, to have everything work here, we're just going to go into packages and command palette and toggle, and we're going to type in install and install packages and themes. And then I clicked on Julia, and then you can click on install language Julia if you want to use Atom like I am using. And that is all I did to set up everything. And basically, to have your code compile, you're just going to type into your terminal, Julia, and I'm going to call this juliatut.jl, and that is how you compile everything. But I don't have anything over here, so let's go and write some stuff. Very first thing I want to do is I want to import some modules. So I want to use printf, and I also want to use statistics. So those are the two modules that I'm going to use in this tutorial. And now let's talk about variables. Basically, types are going to be dynamically assigned and can be changed. So you could start off with an integer and turn it into a string, and there won't be any issues with that. And variables are either going to start with an underline or a letter, and later on you can use numbers as well as exclamation points. So let's go and just define some variables. And you can see here that I can come in and change this to dog, and that's not going to cause any issues. And let's go and just output that just so you can see it. So let's come over here, and there you can see dog shows up. Okay, so that's hello dog instead of hello world. All right, so what else can we do? Well, let's come in. I want to show first off, you are going to be able to assert data types, and if you do, an error is going to be thrown. Let me just give you a demonstration of that. So we're going to talk a lot more about functions later on, but what I'm going to do here is just use this function. This is how we define functions. And so let's go and assert a data type. So let's go int 8, and let's change this to 10, and then let's try to assign dog to that with a string. So we could do this, and this is how we're going to end our functions. All right, so then what we could do is we could come in and call change number, and however, if we do and we run this, you're going to see that that causes an error. So it is possible to assert different data types, but you have to then follow the rules that you are asserting. Booleans are either going to have a true or a false value. So we could say something like can drive, and it's either going to have to be true or it's going to have to be false. Likewise, we're going to have integer 8 as well as int 6, int 32, int 64, and you can see right there all of the different values that in regards to minimum and maximum. And also we have float 32, float 64, and unsigned versions of all of your integers in regards to your different data types. Also, it is important to understand if we go and we create some floating point types that just right out of the box, float addition is going to be accurate to about 14 digits. However, you do have access to other different data types, which is big float as well as big int, that are going to allow you to increase your precision in regards to performing calculations. But just always like to make people aware of this fact, and there you can see whenever everything starts to fall apart. You're also going to be able to use characters, and characters are just going to be surrounded with single quotes. And you're also going to be able to cast two different data types. So let's come in here and let's create a character, and we can go character and 120. And basically characters are going to store UTF-8 Unicodes and we can come in and we can print that out. And I'll show you all multiple different ways that we can output data onto the screen. But let's say that we want to cast from a float to an integer. How can we do that? So let's go I1 is going to be equal to, and we'll go unsigned integer 8, and then what you're going to do is go trunc and then 3.14, for example. That's how we can cast from a float into an integer. Likewise, you're going to be able to cast from strings to floats. So let's go and create that. So we can go parse, and you're going to define what type of data you want to convert to, and then let's say that you have just 1 inside of there. You can also cast from strings to ints. So let's go throw this in there, and you would do that with parse and int 8, just like that. And you can see that as I run it, we don't get any errors, okay? So there's some different ways we can cast to different data types, as well as an introduction to data types, and now I want to talk about strings. Once again, you don't have to do anything special whenever you're defining strings, just surround everything with double quotes. So we'll just say something like just some random words, and you're going to be able to throw in a new line there if you'd like. You can come in and you can get the size of your string just by using length. You could also come in and get the index. The very first index, however, is going to be represented with 1 instead of the normal 0. Likewise, you'd be able to get whatever the last indexed value is by using end. You can also go and get ranges just by going in here, putting in your string, and then let's say we want to go 1 to 4 index. You're going to be able to perform concatenation, so let's go and create a new string just by going string, and then throwing in some random different strings that you would like to use, and then of course print those out. You're also going to be able to use a star symbol here to combine strings, and there's multiple different ways you can do things. So just like this. And you're going to be able to perform interpolation as well. So let's go and create 2 different, let's go 2, and then we'll go I4, being 2 integers that we would like to work with here. We would be able to go in and go print line, and inside of your double quotes, if you want to get the value associated with that variable, you can just do it like that. And then you can perform the calculation directly inside of here as well without causing any issues. That's a lot of stuff. Let's go and run it. And if we run it, you're going to see right here, we have 23 total characters. You're going to see we grabbed the J. Here we grabbed a new line. That's the reason why there's a space there. There we grabbed the first 4 characters. There we performed string concatenation in multiple different ways. And there is our example with interpolation. We're also going to be able to put comments inside of our code just by putting a hash symbol inside of there. We also can go and create multi-line strings just by putting in 3 double quotes inside of there. So I can say something like, I have many lines, and then close that off with 3 double quotes. We can do string comparisons, either using equals to, greater than, less than, or not equal to. So I can come in and go print line, and then directly inside of here, go and see if that is greater than another string. We're going to be able to find the index for characters as well. So let's say we wanted to go find first, and we could say is equal. This is going to give us the very first one, obviously. So I'm going to come in and go and do a search for a character of I, and then I can throw my string inside of here to get that information. We can also find substrings. So let's go print line, and this is occurs in, and let's say we want to look for the substring key inside of the string monkey. And if you see we run that, you can see that we found it. Okay, so there's a rundown of some things we can do with strings, and I'm going to cover a little bit later on, but now I want to talk about conditionals. All right, so let's come in here and let's define an age. And I'm going to say if age is greater than or equal to 5 and age is less than or equal to 6, we want to go and print some information on our screen. So we'll go print line, and you are in kindergarten, for example. And we're going to be able to use a whole bunch of different conditional operators, of course, like greater than, less than, greater than or equal to, less than or equal to, not equal to, just like we're used to. And then we're also going to be able to use and, or, and not in regards to our logical operators. So that's what I'm demonstrating here. And if we want to continue and ask for some more conditions, we can say else if age is greater than or equal to 7 and age is less than or equal to 13. In that situation, let's go and print some more information. We'll say you're in and change this to middle school. And then we can perform even more conditions. So we'll say age is greater than or equal to 14 and age is less than or equal to 18. In that situation, we'll say you're in high school. And then finally, if none of those conditions are met, we'll say else, and then we will print something else here, stay home, all right? And there we go. And then, of course, we're going to have to end this by typing in end. And some other things we can do. Let's use the printf here, just to demonstrate how that works. So I can say at printf, and then we can say true, just to demonstrate how or works, which is going to give us a true if either of them are true or not. And then inside of here, we can say that we want to use a string, and then we could throw in a new line on top of that. And then let's go and I'll show you the ternary operator as well. So I'm going to say here is a condition, and if that is true, then I want to return true as a string, and otherwise I want to return false. So that's the ternary operator. If this condition is true, then it returns this. If it's false, it's going to return this, okay? And let's do another one using printf. And here I'm going to say if we use the not operator on true, what are we going to get as a result from that? Once again, let's throw in a new line. And here what we're going to do is I'm just going to go not true like this, and we'll use our ternary operator once again, and we'll say that we want to return true, or if it's false, we'll return false. Okay, so that's a demonstration of that. And if we run that, you're going to see the results. You're in middle school. If you have true or false, you're going to get true, and the opposite of true is indeed false. Okay, so quick rundown of what you can do in regards to conditionals. Now I want to talk about looping. So I'm going to do a little bit in regards to looping here, and then a little bit in whenever I talk about arrays, which is going to follow right afterwards, and then a little bit later whenever we create a customized do-while loop using macros. All right, so let's say we have I with a value of 1, and we want to come in here and continue looping as long as I is less than 20. Let's say we want to print even numbers. We can say something like if, and then inside of here, we can go I, and this is modulus, which is going to return the remainder of a division. And we can say if that is equal to 0, well, in that situation, we know that we have a even value, and we want to print that out on the screen. Now, if you want to go and work with global values that are outside of this code block, you have to come in and go global, I plus equal to 1. So that's how we work with global values that are outside. And then we could use continue, which is going to skip the rest of the code in this loop. We could then end our if block, and then we could come in once again and go global I plus equals to, and of course if I typed in that, that is of course the same as if we would say I is equal to I plus 1, just like other programming languages. And then we could say something like if I gets to the point where it is greater than or equal to 10, let's say we decide we want to jump out and not continue with all 20 of these, well then we can click on, or we can type in break, which is going to end that, and that's going to end the entire loop. All right, so that's a rundown of how that works. And if we run it, you're going to see it prints out all the even values up until it gets to 10. Well, there are numerous other different ways that we can work with these values. Let's go and get rid of everything except for that. We could come in and use a range with a for loop. So we could say something like for I is equal to, and we want to go from 1 to 5. Let's just get rid of that. And we just want to go and print out what the changing values of I. We can do so. We could also use arrays. So we can say for I in, and 2, 4, 6, or we could put the array in there itself, name-wise, which you're going to see here in a minute, and then we end it with end. We're also going to be able to loop while iterating multiple different variables. So we can just go for I is equal to and go from 1 through 5. And then j is equal to, and then we could go from 2 with a step of 2 the whole way up to 10. So the second part's a step. So it's going to go 2, 4, 6, 8, you know, like that. And let's go and print that out as well. And do that. We can go I and j, and there it is. And there we go. And then if we come in and we run it, you're going to see everything print out right there. Okay, so cool stuff. And like I said, we'll get into more with looping in arrays, which are coming up next. All right, so let's create an array. There's multiple different ways we could create an array. Let's say we wanted to create an array that was full of zeros and is a 32 int, and it's going to be 2 by 2. That's a 2 by 2 array full of zeros. Let's go and create more. There's numerous arrays we can create and numerous ways we can create arrays. So here we're going to say this is going to be integers that are going to have undefined values. And let's say we want to have 5 spaces inside of there. Likewise, we could come in and go create the same exact thing for a float like this. And as you just saw previously, we're going to be able to just throw in different values and it'll create the array automatically for us. We can go and get specific values at specific indexes, of course. So here we'll get it out of the first part of the array, the very first index. We can, just like we did with strings, go and get the last value out of it just by typing in end. We can check if values exist or not inside of our array. So we can come in and go 5 in A4. We could go and get the first index that has a match for what we are looking for by using find first. And then we'll go is equal and the value that we are specifically looking for, which is 2, inside of our A4 array. We can find all the matches using a generic function, which we're going to get more into here later on. So this is a generic function. So we'll go, what it's going to do is it's going to receive a value of a, which it's then going to say if a is greater than or equal to 2, and here's our ternary operator again. If that is true, it's going to return a value of true. Actually, instead of using a string here, we'll use a boolean, and otherwise it's going to return a value of false. And then we can come in and go print line and find all that match our condition that we're going to be working with, and we're going to go and say we're going to call f, which is our generic function, and we are specifically looking for our A4 array. Numerous different functions. I'm trying my best to cover as many as humanly possible. We can also find out how many times a item passes a test. So we can come in, and how we do that is with count. Once again, our generic function, and specifically what we're going to be using here is our A4 array. And if we run that, you're going to see all of those different results. Here we grabbed the very first value out of there. There we grabbed the last, as you can see right here. Here we went and checked if 5 was inside of there, came back as false. Here is the second index, which is equal to 2. There you can see we were able to print out 2 and 3 because both of those are greater than or equal to 2. And then in regards to how many different values inside of the array are greater than or equal to 2, you saw that we get a result of 2 over here. We're also going to be able to come in and get row as well as column sizes. So we can go and print this. And how we do that is to type in size and the array that we want to look at. Likewise, we're going to be able to get the number of items inside of there just by using length instead of size. We're going to be able to sum all the values very, very easily just by typing sum inside of there with the entire array. We're going to be able to put values at a starting index by using splice. So let's say we go splice and exclamation point and the array that we're going to be working with. And let's say that we want to start putting values in as starting at the second index. We would go 2 and 1 like that. And then the items that we specifically want to put in. So let's say we want to put in 8 and 9. That's how you do that. And the 2 is going to be where you want to start putting those values in, if that's at all confusing. And let's go and print out the array just to show you how things have changed. You're also going to be able to remove items at a specific index using splice also. So we can just go splice and the array we want to look at. And then here we're going to go from index 2 through 3. And then once again, just print that out. We're going to be able to get min and max values in a way that's a little bit different. Instead of typing in max like most programs, we're going to type in maximum. And then we're also going to be able to get minimum values just by typing in minimum. You're going to be able to perform calculations on an array without going and getting involved at all with looping, which is kind of useful. So we'll just go A4 and multiply that times 2, and that's going to multiply all the values inside of the array times 2. You're also, of course, going to be able to, well, let's go in here and let's print out A4 again, just so you can see the changes as we are going through all these different things. And there we go. So if we go in and we try to get the row size as well as the column size, there that is. We can see there's 3 items inside of there. We went and summed all those values. Here we went and added in 8 and 9 starting at the second index like we defined right here. Here we went and deleted those specific items we put inside of there. Here we went and got the maximum value, the minimum value, and here we multiplied everything times 2 just like we had there, and then we went and printed everything out again. You're also going to be able to store multiple different data types inside of an array, so this is perfectly okay, just like that. Doesn't matter, and everything works out. Another thing that is really cool is you could actually store functions inside of an array. So we can come in and let's say we wanted to store sine and cosine and tangents. You could do that. And then you could go and get a for loop and then cycle through every item inside of our array, temporarily storing it into the variable, which is n. And then go and actually use n. And let's say we want to go and use a value of 0 on every single thing inside of that array. You can do it. And there you can see that that all worked out, which is pretty neat. We're going to be able to use multi-dimensional arrays as well. And how you create those is just go and put, you don't even need to put commas inside of here. You can just go 1, 2, and 3, and then a semicolon, and 4, 5, and 6. There you go. That's a multi-dimensional array. Now, remember, I can go and cycle through multiple different members if I would like to. So we could go for n is equal to, and we'll go from 1 through 2. And then m is going to cycle through 1 through 3. And let's use printf again for this. So we'll go printf. And if you want to print out a decimal, there you go. Just put that in there. And then we can go and cycle through each of those individual values by going A7 and then N and M. And then, of course, you're going to have to end that. And let's throw a print line inside of there just to have some space. And there you can see if we cycle through all the values in the multi-dimensional array, that's how we do it. Otherwise, we could stack the for loops if you would want to, do that. But there you go. We're also going to be able to, let's say we wanted to get every row in the second column. So we'll go and use our multi-dimensional array, which is A7. And here we're going to put a colon and 2 for the second column. And we could get every row in the second column also. So get this and throw that in there. And the only thing that would change in regards to this is we would change this to 2. And then throw the colon in there like that. You can also create arrays of using ranges. So to do that, and there we are. You're going to be able to create arrays with steps. I briefly talked about this previously, but let's go and do it again. So here's another array, and we can go collect. And here we're going to go from 2 through 10, but we want to step each time by 2. The second value is the step, so it's going to go 2, 4, 6, 8, 8, just like that. You're also going to be able to go backwards. To do that, you do something like 4, and let's do the step, which is going to be -1 and 1. Okay, so multiple different things you can do. And then we could cycle through all these different values. So for n in array 9. And you can put everything on one line also if you'd like. So we could go print line n and then end like this. Another thing that's really cool is you can actually create an array with a comprehension. So we can go A10 is equal to and n to the power of 2 for, throw inside of here a range. And then let's print that out as well. So it just never ends, all kinds of cool stuff. And there you can see how we were able to do that with that range and how we were able to step through those even values using this guy right here. All right, so what else can we do? There's so many things we can do with arrays. We're going to be able to add values to an array. So let's say how we're going to do that is using push with an exclamation mark. So let's do this with the A10 and let's throw 36 on there. We could also create multiple dimensional arrays in other different ways. So we can go A11 is equal to, and then we could go n times m for n in, and then define a range 1 through 5, and then m in 1 through 5 once again. And then let's go and print that array just to see what that looks like. Let's go and clean this code up a little bit. And there you can see we're able to create that multi-dimensional array. And why don't we do one more example? Let's say we want to generate a 5 by 5 random array with values between 0 and 9. We can do that easily. Let's just go and create it. This is how we go and generate random values between the values of 0 and 9. And this is going to be a 5 by 5 array. We could then cycle through and print those out. Here, I'm going to show you how to stack the different for loops for multi-dimensional arrays. So we can go like this, and m is equal to 1 through 5 also, and then let's go and print out all those values. We'll go A12, and then n and comma m to print out both of those, and then end after that, and then we'll throw in a print line after that to throw in a space, and then end to end the for loop. And if we run it, you're going to see it generated all those values and printed them out on the screen. Okay, we will get more into arrays later on, but that's a lot of stuff about arrays. Now we want to talk about tuples. Okay, so a lot of things don't need to be covered again because most array functions work with tuples, except for the fact that tuple values cannot be changed once they are defined. So as long as you're not changing tuple values, you can use pretty much all the things you just saw. So there we went and created a tuple. And just to give you a couple examples, we're going to, of course, be able to get individual values out of the tuple. Once again, they are indexed starting with the value of 1. We can go and get all of the values inside of the tuple with for loops, just like we did before. And there we are. You're going to be able to create multi-dimensional tuples as well. So to do that, you just go 1, 2, and define all of your different values you want inside of there. And let's go and output some value. Let's just go and get the 1, 1 tuple inside of there. There we go. And you're also going to be able to create named tuples. So we could go and define Sue is equal to, and then inside of there throw a string, as well as, let's say it's like a balance or something that she owes, and create Paul is equal to, and then go and throw another string inside of there, and Paul owes us $23 or something like that. And we could go and get the specific information that we want out of there. So there we go, and there we are, and there you can see we were able to get all those information and different ways that we can work with tuples. And I leave it to you to go and explore some of the different things you can do with arrays, also with tuples. Now I want to talk about dictionaries. Now dictionaries are basically key value pairs where the key must be unique. That's the only thing you need to basically remember with dictionaries. And how you create one is you go dict, and then you define your key. I'm going to say pi, and then you're going to define a value you want to associate with it. And let's go and create a couple more of these. All right, so there's a dictionary. And you can, of course, go in here and get different values. So let's go and get the value associated with the key of pi. You're also going to be able to add in additional keys as well as values. Just go like this, and then whatever you want the value to be that's associated with it. You can also delete a key as well as a value just by going delete, exclamation point, and the dictionary you want to work with and the specific key you want to use. We can also come in and check for different keys in regards to whether they exist or not. So we just go has key and the dictionary you want to work with, and then the individual key name. You can also check for specific keys as well as values just by using in, and then you pump inside of that the key as well as the individual value. We can go and say we want to display every single key that is inside of it. So just go keys and the dictionary. And likewise, we're going to be able to go and show all of the individual values by changing keys into the word values. Now let's say we want to cycle through this guy and display both the key as well as the value. We can go for and key value, or KV, in the individual dictionary we have. And then KV once again. And then of course end that. We're going to be able to control how the keys and values are displayed by just changing our for loop a little bit. So we'll go for and key and value in our dictionary we defined. And then here we can go print line and key. And here's another way of juxtaposing your different variables as well as strings. You can just put commas inside of there. So many different ways of doing things inside of Julia. It's really unbelievable. And there we go. And then if we run it, you're going to see, whoops, that I made an error. And I made an error specifically on line number 9. And I forgot to put the N inside of there. So there we are. And you can see all of your different output based off of what we were asking in regards to our dictionary. So pretty cool stuff, something to play around with. Now I want to talk about sets. Now sets are going to be very similar to arrays, except for every value must be unique. So let's go and try to create a set that does not have unique values. You're not going to get an error, it's just not going to allow it. So let's say we wanted to go Jim and Pam, and then let's say we wanted to have another Jim inside of here. You're going to see that Julia says, no, you can only have one Jim. You can, however, come in and add values as well, as long as they are unique, just by using push, and then you're going to say the set you want to work with, and then specifically who you want to put inside. We can then come in and check for individual values using in again. So let's see if we have some random person named Dwight inside of our set. We can check for that. We could also come in and combine sets into a new set, and to do that, we just go and plug that in there using the set again. And then we will use union to combine the sets. So set like this, and there we are. We're also going to be able to find out every item that is in both of our sets that we are working with just by using intersect. In this situation, there aren't going to be any, but we can do it anyway. And then also we will be able to search for items that are both in the first set but not in the second set. And how we do that is set difference and the two sets that we are specifically looking for. And there we can go and run it, and you're going to see the combined sets. You're going to see that Dwight doesn't exist in this set, and you're also going to see the situation in which we check for intersections as well as differences, which there are none. All right, so there's a rundown of sets. Now I want to do a lot of cool things with functions. So let's start off with a simple function. This is going to be what is called a single expression function. So it's called getSum. It's going to receive an x and y value as attributes that are passed into it. And then it is going to add those values and return it. All right, that's all we do. Then we can go and define two different data types here, all on one line, and give them the values of 1 and 2. And then we'd be able to come in and go printf, and let's go, and this is going to be an integer plus another integer is going to be equal to, and then another integer, and then throw in a new line inside of there. And we can get the value of x, we can get the value of y, and then we can get the value of x plus y. And then we can call our function getSum and pass x and y inside of it. And if we do that, you can see we got our result. All right, so that's the most simple type of function we can work with. But of course, there's also multiple expression functions. So let's go, and how you define the function is type in function, and then I can say something like, can I vote? And let's throw age inside of there. And if we want to provide a default value for our argument, you just put equal to whatever it is. Then we can say if age is greater than 18. And we can print out then in that situation, you can vote, you lucky devil. And else in this situation, we can come in and say that you can't vote. All right. And then we close off our function, and then we just call our function just by going can I vote, and then we can throw in something like 43, and can vote pops back. All right, so there's a multi-expression function, and let's do more. It's very important to understand that your arguments are going to be passed by value. So if we come in and define our value right there, and then we go and create a function inside of it, and we call it change vi or v1, and then pass in v1, and then try to change that value to 10, and then end it, and then go and call our function change v1 and pass in v1. However, then we jump down here and we go print line, and then we type in v1 once again. That value is not going to change. One way that we could go and change it is to define it as our global, just like we did previously. So global v1, and then we would go and get rid of this guy right here, and then go and get rid of this also, and run it. And here you can see that we were able to change it just by using the global keyword inside of there. All right, so there we go. And let's go and create another example. So let's say we don't know how many different arguments a function may get, and we want to be able to accept multiple ones. Well, let's go and create the upgraded version of getSum, getSum2, and we go args, and then 1, 2, 3 like that, and that is going to allow us to get as many arguments as we want. So just make sure if you want to use this with other different variables that this is always the last thing inside of there. So we can go a in args, and then we can go sum plus equal to a, and then close that for loop, and then we could do a print line and the sum inside of there, and then end the function altogether, and then we can go get sum2, and then go 1, 2, 3, 4, whatever we'd like, and run it, and there you can see is that final value. You're also going to be able to come in here and to return multiple different values. So once again, function, and let's say next to is the name of this function. It's going to receive a value and then return the next two values afterwards. So we'll go return, and we can go val plus 1, and then val plus 2, and end. We're then going to print out those results. So we'll go next to, and let's say we throw 4 inside of there. And you can see we get 5, 6 back. All right, so many things we can do with functions. Let's do some more. We can have functions that return functions. So I'm going to call this make multiplier, and we're going to get a value here, and then we're going to create a custom function that's going to multiply times whatever that is. So here we're going to go return and then define function directly inside of it. That function is going to receive an x value, and it is going to return x times whatever the num is, and end. Then we can go like this. Then we can go and create that custom function that's going to multiply times 3 just by defining that and calling make multiplier and passing in the value of 3. Then what we can do is go and print this here and call mult3 times 6, creating custom functions to get a value of 18. Okay, so neat, and there is more. We can also handle different types of arguments. Let's throw this inside of here. So we can go and create getSum3, which is going to receive a number, and it is going to be of type number, and num2, which is also coincidentally going to get a number data type. It is then going to return number 1 plus number 2. And then we end that function. Then what we can do is do pretty much the same exact thing. It's going to be almost identical. So it's going to have exactly the same name. And this one's going to work with strings. So we're going to do this like this, except we're going to change the number into strings. So there's a string, and there is another string. And we just need to convert these into, or from strings into integers. So I showed you how to do that earlier, but I'll show you again, just in case you missed it. So do that, and then once again, we will go parse and int 32. And the number we want to convert from a string into an integer. And then we can come in and go print line, and 5 plus 4 is equal to, and then a comma, and getSum3 is the name of that, and we can pass in a 5 and a 4, and then we will do a very similar thing for the other situation, except in here we're going to put quotes around this so that this is a string, and you're going to see that even though those are two different types of data, that it's going to work. All right, so cool stuff. That's the specifics of functions. Now we want to talk about anonymous functions. Now, an anonymous function is a function with no name that is normally used in line, and I'm going to show you a bunch of examples here. So let's go and use map, which is a super awesome function that's going to apply a function to each item in an array in this situation. So we'll go x and like that. And then this is going to be our anonymous function. It is going to receive a value of x and then multiply x times x. And it's going to do that for each value in our array that we have. And then what I can do is print out that value. So very, very simple, cool stuff. All right, so there we are. All right, let's do another example. Let's say we want to add arrays. So we'll go v3 is going to be equal to map, and it is going to receive, again, this is an anonymous function. These represent the attributes of the anonymous function that doesn't have a name. And what it's going to do is just go and add the different values in the array to each other and then output an array. So we'll go 1 and 2 is the first part, and then we will go 3 and 4. And change this to 3 and change it and run it. And there you can see we were able to add the 1 to the 3 and the 2 to the 4 and give us another array. Another function that's very useful is reduce. And what this does is it uses a function multiple times to finally get to one result. So let's go and create v4 is equal to reduce. And let's say we want to add every single value that is going to be between a range of 1 and 100. And we want to output that. It will do it. And there you can see is the value. And we can do even cooler things. Let's say we wanted to find out what is the longest word in a sentence. Well, we could do that. We'll go sentence, and we'll just say this is a string. And then we can convert our string into an array. So to do that, we just go split like this and the sentence that we're working with, and then we can go and get longest, and that is going to be equal to reduce, and we're going to get the first value in the array and the second value in the array, and we're going to run length on the first one and see if it is greater than the length for the second item. And here is our ternary operator again, so x, otherwise it's going to return y, and we're going to perform this operation on our entire array that we have. And then after that, we can just come in and print out longest. So you can see these are extremely powerful tools that can be used to do really cool things if you don't create an error. 16, oh, I just spelled longest wrong. All right, fixed it. And there you can see string comes back, and string is the longest string in this string. All right, so there we go. That's a cool thing we can do with reduce. Now, being that Julia is such a mathematically inclined language, of course, there's numerous different math functions. I can't even begin to touch them all. Of course, we're going to be able to add, subtract, multiply, divide, modulus. This is the power function. We're going to be able to round values. Floor, it's going to round down. Ceiling, round up. Absolute values, square root, cube root, hypotenuse, exponent, logs, different types of logs, and numerous different types of trig functions are all built in. Also, we have, of course, I talked about this briefly. This guy right there is a shortcut. So for example, if you would go I plus equal to 1, that is exactly the same as I is equal to I plus 1, okay, just like other languages. You're also going to have subtraction, multiplication, equals to, the power function itself, and so forth and so on. Another thing that's really neat is you can actually imply multiplication. So let's say you have x is equal to 5. You're going to be able to come in and go print line. Whoops, you have to be very careful with white space. So you're also going to be able to come in and go 2 and x, and this is going to cover all the different stuff. But here you can see we got the value of 10 right there. So that's really neat, really nice way of printing out formulas. And another thing that's neat is the dot operator is going to allow you to perform operations on arrays. Julia loves arrays. So we'll go 1, 2, and 3. And we can print this out and go A13. And then if you want to multiply everything in the array by 3, for example, you can do so. And you're going to see the result of that array right there. All right, so cool stuff. Just a whole ton of different math functions you can play with inside of Julia. And now I want to talk about enumerated types. All right, so enums, let's just say we want to go and to create an enumerated type. Let's go and say we want to have it be called color and begin, and then you just start defining all your types. You can associate different values with said types. So blue and 2 and green is going to be equal to 3, like that if you would like. And then you could do something like favorite color is equal to, and green and color referencing the type, and print line and favorite color. And whenever you do that, you're going to see that green comes back. All right, so real brief explanation of how you can work with enumerated types inside of Julia. Trying to move quick. Let's talk about symbols. Now, symbols are just immutable strings that represent variable as a data, and how you create one is you just go like this. And we can then go print line, and whenever we go to print out our symbol, whoops, get rid of those double quotes, you're going to see that we are able to do so. And there's Derek. And symbols are very commonly used as keys with dictionaries. So we could go and create a dictionary, and there it is. And instead of putting those different quotes inside of there, or the different strings inside of there, we can just use a symbol, which is very common. And 314, and let's do another one with E is equal to 2.718. Whoops, get rid of that. What am I doing? Let's go. There we go. And there we go. And then we can come in and print that out just by referencing our dictionary that we have, and then the specific symbol that we want to work with. And there you can see that works. All right, so cool stuff with symbols. And now I want to talk about structs. Now, structs are composite types, or specifically a type that can contain many different fields. I'm going to give you a couple different examples of how to work with them. So let's say we want to create a custom type called customer. And it is going to have a name inside of it, maybe a balance that is due, and you can use all kinds of different data types, of course, and let's say an ID just to do something. All right, there it is. All right, and we're going to end that. Then what we're going to do is create a customer object. So we can say Bob is equal to, and use customer inside of there, and then we can throw in Bob's full name, Bob Smith, and then the balance Bob owes us, as well as an ID. We're then going to be able to go and get specific information. So we can say Bob name, for example, and you can see Bob Smith comes back. Now we're going to be doing more and more complicated stuff here. So one thing that's important to remember is structs are going to be immutable. So for example, if you tried to come in here and go Bob name, and let's say Bob changed his name to Sue Smith, well, Julia says that is not okay. So we cannot do that. That would give us an error. However, you would be able to get mutability inside of here by just going mutable, okay? Mutable struct, and then in that situation, you would be able to go back and change it. All right, so we got that out of the way, and now we want to cover a topic that is very similar to structs, and that is abstract types. Okay, so let's go, and basically abstract types can't be instantiated like structs. We can't create customer objects like we just did, but they can have subtypes. So let's go and let's create a abstract type, and it is called animal. All right, so from that we will then create a struct called dog that is going to be of type animal. And then we will say name, and this is going to be a string, and then bark, which is also a string. And then let's go and create another one, which is going to be cat. And so let's change this to cat. So both dogs and cats are both animals. And the difference here is this is going to be meow. So they both have names, but they'll have different ways of emoting. So what we can then do is go Bowser is equal to dog, and then pass in Bowser like that. And then we can pass in rough as well like that. And then we'll do something similar for Muffin. And this is going to be cat named Muffin, and meow is her thing. Now what we can do is we can create two functions with the same name, just like we did previously, and work with either one of them. So we can go sound, make sounds. We can refer to them both as animal types. However, this is specifically for dog animal types. And then we can go print line, and we can go and use interpolation, which I talked about earlier. Animal name says and then again, animal bark. So we're referencing those guys, and then we can make a copy of this and then just make this work for cats. So like that, and then change this to from dog to cat, and then we will change this to meow, and they will both work if I actually call them. All right, so let's go this and make sound, and then we will pass Bowser in, and then we will pass in the muffin as well. So there's Muffin and Bowser, as long as I didn't type anything wrong. And you can see Bowser says rough and Muffin says meow. Okay, so cool stuff. Now I want to talk about exception handling as well as user input. Okay, so with exception handling, of course, we're going to be able to throw as well as handle errors. So let's say we want to get some input from the user to perform a division. So we'll say that we want to have them enter a number, and then we want to store that number. And how we want to get rid of the new line at the end of their input is by using chomp, and read line is going to get the value that the user enters. And we'll do this, and then we'll change this to number 2. Now what we can do to protect against a division by 0 is go try, and value is going to be parse, and we need to convert from the string to an integer for num1 as well as num2. So let's go and copy this, and then we can do a division and throw that inside of there. And Julia considers the division by 0 to be equal to infinity. So we'll say if value is equal to INF, which is infinity, we want to throw our custom error, which is going to be can't divide by 0. So there is the error we're going to throw. Else, we're going to just give them a result. So we'll say value, and then of course we have to end that. Then we need to catch our specific error. We'll go catch E, we'll catch it, and then we can just go and print E out, which is going to include our error message that we had inside of it. So cool stuff. This, enter a number, and we'll go 10, enter a number, 0, and you're going to see can't divide by 0 comes back. Otherwise, if we go and do something like 10 and 5, we're going to get the result we expected. Okay, quick example using exception handling. Now I want to talk about file I/O. Okay, so if you want to be able to read and write from files, this is how you do it. You're going to go open, and you can just type in whatever. So let's go random2text is the file we want to work with, and if it doesn't exist, it will be created. Then we're going to say we want to write to it, and then we're going to say do file, which is where everything's going to be. And we can say write and file, where we're going to save this information, and we could say something like, here is some random text, text, throw in a new line, which is going to, be the line, and then we can say it is great, and throw in another new line, and then we can end it, and that is going to automatically close the file. We will then be able to open our file for reading in much the same way. So here, what we're going to do is go open the same file, except we're just going to get rid of this right here. And then we want to read in all of the text from our file. And to do that, we can just call this data is equal to, and we'll call read and this file that we're looking for, and then string. And then let's say we want to print all of that information, just throw data inside of a print line, and then end closes it once again. And then we could also go in and open our file and read it one line at a time if we'd like to. So we'll just go once again, here is our file, and then do file, and then let's get rid of this guy right here. And let's say we want to read it one line at a time. We can go for line in each line and the specific file we're working with, and then we will print those out, and you're going to see that the result looks very similar. And then end, and then if we run it, you're going to see that we went and wrote to the file, we accessed it, read it out once, and then did it again. Okay, quick example of files. Now to finish off the tutorial, I want to talk about macros. Now I could do an entire tutorial on just macros. I'm just going to give you 2 examples. Basically what macros do is they generate code for you before a program is run. So I'm going to create 2 examples here. How you create a macro is you just type in macro, and I'm going to give it a name. I'm going to call it do more, which is what it's going to do is it's going to receive a value which it is going to define how many times we're going to run an expression. Okay, so there that is. Now I'm going to type in quote inside of here. And what quote is going to represent is the beginning and the ending of running our code. And then I'm going to go for I is equal to 1 through and $, and escape. And escape is going to hide what it contains until everything is ready to be executed. So we're going to go from 1 through, this is a for loop, 1 through how many times the user defines we want to execute our code. And then once again, we're going to go escape, and the expression, oops, make sure to put all the parentheses inside of there, the expression that we want to execute. So we're going to execute the same expression multiple different times using this macro, and it's going to automatically generate all of the code to make it work. All right, so let's run it. So to run a macro, you go at, and whatever the macro's name is, and let's say we want to print hello 2 times. So we'll go 2, and then we pass in the expression that we want to have executed, which is hello 2 times. All right, and if we run it, you're going to see it does just that. And we can change it to 3, and guess what's going to happen? It's going to run it 3 times. All right, so cool stuff. So let's go and create another macro. Let's say you want to create a custom do while loop inside of Julia. How would you do that? Well, let's go macro, and let's call it do while, and it's going to receive the expressions that you want to execute. Well, what I want to do here first is assert that while is going to be the first element passed inside of it. So I am going to say that we must have while, and how we access the first element passed inside of here is to go and get the expression passed inside of here, obviously, and then follow that with head. And we want to say that we want to guarantee that that is equal to while. All right, again, we're going to use quote, and like we said before, it's going to represent the begin and end block, for our code. It's going to generate that for us. So let's go and get quote. Then what we want to do inside of here is we want to verify that we just want to get all of the different stuff that's going to be inside of our do while block and paste it inside of there. So this is going to represent the body of our loop. So once again, we're going to escape this out, and we're going to go args and 2. And then after that, we will go and get our expressions again. After that, we're going to go and type in end, and then once again end. All right, so now that we have that set up, we have essentially created a do while loop. So we're going to go 0 is equal to 0, and then to call our do while loop, we'll go at and do while, and while z is less than 10, we will, let's reference the global z plus equal to 1, and we will print out all of the values, of z. And then we'll close off with end, just like we did before. And if we run it, you can see that it cycles through and prints out the values 1 through 10. All right, so 2 very simple examples for macros. Didn't want to do a long-winded tutorial on macros. Maybe I will, depending upon if you guys leave comments saying that's what you want to see. So there you go, guys. There is the core syntax of the Julia programming language. Hopefully you enjoyed this tutorial series. And like always, please leave your questions and comments below. Otherwise, till next time.